Let's look at convolution and theorems related to convolution. So, what is convolution itself? It's a mathematical operation on two functions that produces a third function, expressing how the shape of one function is modified by the other. So, mathematically, again, let's look at the formulas involved that. So let's say if we are interested in a function called f of t and g of t, if we want to apply convolution between these two, we use this symbol, and this is defined as integral from 0 to t of f of u times g of t minus. This is what is the convolution. By the way, convolution term is used both for the process involved in uh, arriving at it and the result as well. So now based on this, let's look at some theorems. If f of t and g of t are functions defined for t greater than 0, then Laplace transform of f of t convolved with g of t is equal to the Laplace transform of f of t times, and this is your normal multiplication, Laplace transform of g of. And let's say we have to prove this. So how do we go about proving this? So first let's remind ourselves about the Laplace transform. So Laplace transform, as per that, Laplace transform of let's say a function f of t is equal to integral 0 to infinity of e to the power of minus st f of t dt. This is the Laplace transform. Now what we'll do is we will start off with this left hand side and try to arrive at the right hand side. So by convolution, so we have Laplace transform of f of t convolving with g of t. Now let's apply the Laplace transform, right? So when we apply that, what do we get? We get integral 0 to infinity of e to the power of minus st, and then what? Instead of ft, we are going to put this, right? So f of t convolving with g of t dt, right? Okay, now we'll apply the convolution. So e to the power of minus st, and now we'll apply the convolution, right? This one. So that would be 0 to t of f of u times g of u minus, no, t minus u, t minus u du and dt. So this and this. So I have applied the convolution. So now remember here, this part is with respect to u. Integral is with respect to u, and here there is no u. That means it is a constant as far as u is concerned. So that means I can take it in. Normally what we do is we take out the constants out of an integral. Now here I'm going to take it inside. So 0 to infinity, 0 to t, e to the power of minus st f of u times g of t minus u du dt. Now let's see, integral 0 to t of. Now if you look at this doesn't contain t, right? This has t, this has t, so we can bring in t inside, and take f of u out. So f of u out, it goes out of this integral. And here I am left with e to the power of minus st g of t minus u dt and du, right? So this part is one integral and this is the second integral. How do we solve this integral? Let's do some substitutions. So let's say t minus u is equal to v. That means t is equal to u plus v. And if we differentiate it with respect to v, what do we get? dt by dv is equal to 1. So that means dt is equal to d. Now, when t is equal to 0, v would be equal to 0. When t is equal to infinity, v would be equal to infinity. Yes? So basically what are we doing? We are basically changing this integral interval from 0 to t to 0 to infinity, right? So let's rewrite that integral. So 0 to infinity of f of u, and then let's put a bracket here, 0 to t. This becomes infinity. When t is equal to infinity, v is infinity. Okay. E to the power of minus s. T is what? T is u plus v. G of v dt is dv, and this remains du. Integral 0 to infinity of f of u, integral 0 to infinity of, let's split it up, e to the power of minus su times e to the power of minus sv, gv, g of v dv du. Here again, with respect to v, we are integrating. So this is a constant because there is no v there. So we can take it out. 0 to infinity of f of u e to the power of minus su, integral 0 to infinity of e to the power of minus vs g of v dv and d, right? Now if you notice, when we integrate this, we will get a constant. Yes, we will get a result which is going to be a constant. So which means we can take it out of this integral, right? So I'm taking out vs g of v dv. I'm taking it out and I'm left with 0 to infinity of f of u e to the power of minus s u du. Be very clear here, this integral result would be a constant. So since it with respect to u, right, because u doesn't appear anywhere, so which means that this being a constant, we can take it out of this integral. So which means it becomes a simple multiplication. Now, what is this? This is nothing but, as per the definition of Laplace, is the Laplace of g of t. And what is this? This is again the Laplace transform of f of, and since it is a normal multiplication, it is commutative. So Laplace transform of f of t times Laplace transform of g of t, which is nothing but the right hand side, right? See here, Laplace transform of f of t times Laplace transform of g of t. And what is the left hand side? Left hand side is the Laplace transform of f of t convolving with g of t. So to evaluate the Laplace transform of the convolution, we arrive at the product of the Laplace transform of the two functions. Now let's verify this. Okay, so to verify, let's take an example. let us say f of t is equal to 1 and g of t is equal to sine of t, right? So Laplace transform of f of t is the Laplace transform of 1, which is equal to 1 by s. Now remember, you need to have a table of Laplace transforms. Similarly, Laplace transform of g of t is equal to Laplace transform of sine of t, which is equal to 1 by s square plus 1. Let's multiply this. So Laplace of f of t times Laplace of g of t is equal to 1 by s times 1 by s square plus 1, which gives us 1 by s times s square plus 1. Okay, pretty straightforward. Now let's do the same thing using integration, right? So 0 to t f of t minus u gu du. Yes, let's do the substitutions. Now remember, f of t is equal to 1. That means anything that you pass to this function, it will be 1. So which means this is 1. And g of u is sine. So sine of u dk. Now let's integrate. We can ignore 1. So sine u integral is minus cos u from 0 to t, which is equal to minus cos t minus minus cos 0, minus cos t minus minus 1, which is equal to minus cos t plus 1, right? This is the first step. Now we have to take the Laplace transform of this. So Laplace transform of minus cos t plus 1 is equal to, now for minus cos t, the Laplace transform is minus s by s square plus 1 plus Laplace transform of 1 is 1 by s. So minus s square plus s square plus 1 divided by s times s square plus 1. S square gets cancelled and we are left with 1 by s times s square plus 1. And here if you notice, this is the same as this. The difference being we had to go through this entire process of integration. So that integration gets converted to simple algebraic operations. That's it. Bye.